All right, let's dive into one of the biggest debates in the developer world. You're spinning up a new project and you hit that first major decision. Which database are you going to use? Today, we're putting two absolute titans of the open source world head-to-head, MySQL versus PostgreSQL. This isn't just a minor choice. It can shape your entire application's future. So let's break it down.
So you're there, right? You're ready to start coding, the architecture is taking shape in your head, but then you hit this wall, MySQL or Postgres. It feels like a simple choice, but the database you pick is going to stick with you. It's going to affect your performance, how you scale, and how complex your life gets down the road. So yeah, it's a big deal. How do you make the right call from day one?
You know, the easiest way to think about this is to give them personalities. In one corner, you've got MySQL, who I like to call the speed demon. It's all about raw, blistering speed and simplicity, especially for applications that are mostly reading data. And in the other corner, we have PostgreSQL, the data guardian. This one's the heavyweight champion of data integrity, packed with advanced features and built to handle seriously complex stuff. That difference in philosophy, it's everything.
Okay, so to really get why they're so different, we need to pop the hood and look at their fundamental DNA. This is where it all starts.
MySQL is what we call a purely relational database. Just think of classic, clean spreadsheets. You've got rows, you've got columns, and you can link tables together. It's simple, it's effective, and it's perfect for most web apps. But then there's PostgreSQL. It's an object-relational database. It takes all those great relational ideas and then starts borrowing cool concepts from programming languages, things like inheritance and creating your own custom data types. It's way more flexible, which is a game changer for more complex applications. All right, let's get into a topic that every senior engineer has to wrestle with: concurrency. I'm talking about what happens when you have thousands of users hitting your database all at once, reading and writing. How do you stop it from turning into total chaos? Well, the magic word here is MVCC. So what in the world is multi-version concurrency control, or MVCC? Look, in the old days, if someone was writing to a piece of data, everyone else had to wait. It was like a one person at a time bathroom key. Awful for performance. MVCC is a much smarter system. Instead of locking things up, it basically creates different versions of your data. This means readers never have to wait for writers, and writers don't have to wait for readers. They each get their own clean snapshot of the database to work with. It's absolutely crucial for modern apps.
And Postgres has a really beautiful way of doing this. Here's the flow. First, anytime you start a transaction, it gets a unique ID. Then when you update a row, Postgres doesn't actually delete the old one. Nope. It just creates a new version of that row and tags it. When your transaction started, it took a snapshot, a picture of the database at that exact moment. And for the whole time you're working, you will only ever see data that was confirmed and committed before your snapshot was taken. It's a brilliant way to keep everything consistent and isolated. And here's a massive difference between the two. For PostgreSQL, MVCC isn't an optional extra. It's baked into its very core. It's just how it works, period. With MySQL, well, it depends. The modern, default engine, InnoDB, uses MVCC just like Postgres. But if you happen to be using an older engine like MyISAM, it uses something called table-level locking. Table-level locking is like trying to edit one sentence in a Google Doc, and it locks the entire document for everyone else. It can create huge bottlenecks. So with MySQL, you really have to know which engine you're using. So all this technical talk about architecture is great, but how does it actually play out in the real world? Let's connect these internal mechanics to actual speed and performance under pressure. Let's just lay it all out. When it comes to handling many users at once, Postgres has that universal MVCC. MySQL's got it too, but only in InnoDB. For queries, Postgres has this incredibly smart planner that's amazing at figuring out the best way to run really complex, gnarly queries. MySQL's planner is more streamlined. It's optimized to make simple reads happen at lightning speed. And for scaling, MySQL is famous for horizontal scaling, just adding more machines. Postgres is a beast at vertical scaling, making one machine more and more powerful. See the pattern? Postgres is built for complexity. MySQL is built for speed. Now, because of that whole object-relational thing we talked about, PostgreSQL has some really cool features that MySQL just doesn't. Let's look at some of its superpowers. First up, table inheritance. Now, if you've done any object-oriented programming, this is going to sound super familiar. You can create a parent table, say person, and then have child tables like employee and customer that automatically get all the columns from person. It's a really clean and natural way to model your data.
And this one is a big deal. PostgreSQL lets you create your own data types. You can create something called a domain, which is like a regular data type but with your own custom rules attached, like, say, an email address type that automatically checks if the text is a valid email. Or you can create composite types, which are basically like a struct or a class in your code, bundling multiple fields together. This lets you enforce data integrity at the deepest possible level.
And we can't ignore security, especially when we're talking about advanced features. Postgres is built like a fortress. It uses modern secure password hashing. It gives you incredibly fine-grained control with roles. And it has this killer feature called row-level security, which means you can control not just who sees a table, but who can see a specific row in that table. For building secure multi-tenant apps, that is an absolute game changer. It's truly enterprise-grade.
Phew. Okay, we've covered a ton, from the core philosophy to concurrency to superpowers. So let's bring it all home. Let's build a simple framework so you can confidently pick the right tool for the job. So when do you reach for MySQL? Simple. When your priority is speed and simplicity. If you're building a blog, a standard e-commerce site, or any app where you're doing a ton of reading, MySQL is an amazing choice. It's easy to get started with, it's fast as heck, and there's a reason massive projects like WordPress have relied on it for decades. And when should you pick PostgreSQL? You pick it when things get complicated, when you're dealing with complex data, running analytics, building a financial application, anything where data integrity is absolutely non-negotiable. If you need to store things like JSON documents, geographic data, or complex arrays, and you need to handle a lot of concurrent users without breaking a sweat, Postgres is your champion.
And really, that's what it all boils down to. It brings us to the one question you have to ask yourself before you write a single line of code. For this project, right now, what's more important? Blazing fast reads and simplicity, or rock-solid data integrity and the power to handle complexity? The speed demon or the data guardian? Your answer to that is going to tell you exactly which database you should choose.